Welcome to Django Models CRUD. After watching this video, you will be able to use Django Model APIs to perform CRUD operations on objects. The most common operations on data are create, read, update, and delete. Django Model provides comprehensive CRUD APIs to manipulate objects without writing SQL queries. Let's review the online course models we will use for our examples. The base user model contains common information about our instructor and learner models. Instructor is inherited from the user model and has fields like is full-time or total number of learners. Learner is also inherited. It has fields like occupation and social link. The course model has many-to-many relationships with both the instructor and learner models. Course model also has many-to-one relationship with the project model. In a Django model, you create an object and call the model's save method to insert it into the database as a record. Here, we have created and saved the object Course Cloud App. If the object you create contains a reference to another model, such as a foreign key or many-to-many field, you use the related model reference to create a relationship. We have created a project object and referred its course foreign key to the Cloud App course we just created. Once we have inserted objects and their relationships into the database, we can query them. First, let's see how to read all objects for a model. This is equivalent to using select star from a table to get all table rows in SQL. In general, to read objects using Django Model API, you need to construct a query set using a manager on your model class. A query set represents a collection of records in a database. After you have defined your model by subclassing a Django model, such as course in our example, you can use its model manager as an interface to access database records. By default, the name of the model manager is Objects. You can only access the Objects Manager using the model class, not the model instance, to enforce a separation between table-level operations and record-level operations. To get all course records, use the manager's all method that will return you a query set object. In the output, you can see that all courses were returned and included in the query set object. Usually, you'll just need a subset of records instead of the entire table. To create a subset of part-time instructors, you refine the initial query set by calling a filter method. The filter method can have many lookup parameters, such as greater than, less than, contains, or is null. This is like the condition usage in the SQL where clause. Lookup parameters contain the field name and the query expression, which can be empty for an equal check or separated by an underscore for other checks. In this example, we're checking that the Boolean field is full-time is false to create a subset of only part-time instructors. The course model manager will return all part-time instructor objects contained in a query set object. The exclude method returns a new query set that does not match the given lookup parameters. Since both the exclude and filter methods return a query set, we could further append exclude and filter methods to form a filter chain. This is like adding multiple conditions using AND in a SQL where clause. We can find a subset of instructors using both exclude and filter. First, we use the exclude method to remove all part-time instructors. Then we apply two filters to find instructors with more than 30,000 learners and a first name that starts with J. Another way to apply multiple filters is by adding multiple lookup parameters in one filter method. And we can see that the target query set has been returned. If there is only one object that matches your query, you can use the get method to return the object. For example, if we know there's only one instructor with the first name John, we can use the get method with a first name lookup parameter to get the instructor. In our previous model design, many models were related using relational field references. For example, the course model had a many-to-many field reference to the instructor model. From an object point of view, these composite fields are references to related models. From a SQL perspective, these fields are foreign keys pointing to related tables and could be joined to obtain related information. When querying related records in a database, Django handles SQL join automatically, so you can read related objects using references. You can also create lookup parameters on the related fields in other objects. For example, to find all courses with an instructor whose first name equals John, we can create a lookup parameter with the related field called instructors, followed by a double underscore, then followed by an instructor's field called first name. We have seen how to insert records into a database and how to read data using Django models. Now let us see how to update database records by updating objects. One way is by updating the primitive fields of an object. For our learner object, we can change the date of birth field to March 16, 1985, and use the save method to update the change to the database. The Django model will create and execute the corresponding SQL update statements. We can also update the related fields, such as the foreign key field or the many-to-many field. For example, we can update a course foreign key field so it points to a different course. We can also use the add method to add another learner to a course. To delete records in a database, you call the delete method on a model object or a query set. Django ORM supports different on-delete options. You will learn more about these later. In this video, you learned that with Django APIs, you can perform actions on data in databases without writing SQL queries. And you can use Django Model APIs to create, read, update, and delete objects.